Welcome back to the next tutorial on Mathematica. In the first video, in fact, the first on all the tutorials that are to be coming, I sort of introduced you to graphing, making our first graph, which was a graph of a parabola on Mathematica, and I did that on my nifty Mathematica program over here, um, and I think it was this window over here, and we used the plot instruction to pass on the argument, the function which we drew over here, the parabola, and the range of values that the variable x could take. Uh, Good, and I got this graph, but there was a problem. This graph is not the same as this graph over here. I mean, you can make it larger, click on it and drag it to make it larger, but background not the same. Also, this graph, I mean, as the function itself indicates, it's a parabola in its perfect square form. So if it's a plus 100, we know that means that it means it's shifted 100 units to the above, which I see in this graph over here because the origin is at 0. But when I look at this, the origin is not at 0. The origin is 100, which is an issue. So in this tutorial, I will essentially show you what other arguments can the plot command or the plot instruction take to give us much more, to give us those graphs that we want Mathematica to give us, rather than the default graphs that you get just by entering a function and then entering the function's domain, or the set of values that the variable in that function, in this case x, can take. First, I'm going to fix, let me make the window a bit larger. Okay. So I have the function. The origin is 0. In this case, the origin is not 0. There is an argument called plot range. And you may have noticed that when it's just a word, which is not a command in Mathematica, it's blue colored. Maybe I should zoom in if it's not clear. It's blue, but the moment I write a proper Mathematica instruction, which is plot range, it's black. So whenever you see a blue thing, it always means it's just an alphabet or a letter, and not a function. X in this case is a letter, that's why it's blue, and that's blue for letters or any type of words that is not a command in Mathematica. And the notation for plot range is dash, and then I think we call these greater than signs, space that becomes an arrow. And because my range should be from 0, beginning at 0, the range should begin at 0 and go up to, in this case, it went up to 170. I mean, I can always arbitrarily choose a very large upper limit for the range. I say 0 beginning, and let's end it at 300. And that's because in this graph over here, the one I had shown to you in the first video, I had made it go from 0 to 300. Okay. 0 to 300. And not to forget my curly brackets, close. And the really easy part in Mathematica is, well, I just made a modification to this. I don't need to do the entire thing. I'm just gonna bring my cursor anywhere over here, click and press Shift Enter, because Enter takes me to the next line. But Shift Enter will tell Mathematica to do the instruction I gave it. Shift Enter. Voila. Okay, so it looks much better, and it looks proper, and it looks much the way this one looks over here. Ouch. Okay, oh no, my computer's okay. It's not Not collaborating on what happened. Oh, I zoomed out too much. Okay, I think I have to zoom. Okay. Ah, thank God. Okay, so it zoomed back. Oh, what happened to this? Okay, some technical difficulties over here. Should I edit this out? I don't know. Okay. Hmm. Okay. There we go. Okay. Maybe touch too much zoom. Okay, that looks good enough. I have I have brought my parabola back, so now the range is correct. Mathematica over here. Okay, so the range is correct. What is missing though is the background color. So let me add the background color. To add the background color, and again, you might be wondering, well, Ami, how do you know all these commands that plot takes? Plot is sort of the in this case is the universal command, and within plot we have, we are putting the function as an argument, we're putting its variables values as an argument, which in math class we call the domain, and also the y values of the function, which we call range. In this case, the name is aptly named plot range, 0 to 300. Could have been 0 to 500. Ouch! What happened? Oh, so I forgot a comma without an argument. That's a problem. Okay, let me redo it now. Shift Enter. Okay. So yeah, now it's 0 to 500. So I can play with it, but this allows me to fix the range of y values that the graph will show. Once I have my plot range, I can now have a background color to it, and all these commands that plot takes can be found on Mathematica's website. You can do a quick Google search on it. Plot, plot commands, plot instructions, and then you should be able to see these coming up on the Google or Yahoo search or Bing search. Background. Let me zoom in. Background. Again, the same notation. Dash greater than sign becomes an arrow after a space. Background color. In this case, it was a pink color. So, but I mean, pink color we can get pink color in many ways. One way, I think the way I had used RGB color, and it's good because it's not blue. It's a black thing. So it's another command, RGB color. And if I remember correctly, RGB color takes 3 arguments. If it's 1, 1, 1, okay, 1, 1, 1, and I shift enter. Whoops, okay, forgot, okay. Oh, no, okay, forgot. The brackets have to be completed. So plot has a square bracket, opening it up, and a square bracket opening it up, and square bracket closing it. Okay, but every other command within plot will also have to have the same. If you have if the square bracket opens, it has to close. Okay, my bad. Shift enter. I don't see anything. The background just looks like white again. Okay, let me try 0, 0, 0. Shift enter. Oh, it's totally black. Okay, so how about 0 0.5, 0.5, 0.5. Shift enter. Okay, it becomes gray. Okay, so it kind of makes sense. I mean, RGB color works. I mean, I might go off a bit of a tangent, but let me see if I have another notebook opened up. Okay, good. So RGB color is. Let me open up my swatches. Okay. In computers, like there's red, and then there is green for G, and blue. Blue. And like I might make a video on this later, or you can do a quick YouTube or Google about RGB color. But just to give you a quick sort of understanding of how RGB colors are made, is each color in a computer screen is composed of pixels. So a pixel is like, okay, it's this nice square with same length and same width. And a pixel can have any color. It could be it's a unique color. It could be red, it could be a bit pink, it could be blue, it could be orange, it could be any color, but the color comes from a combination of red and green and blue. Now the combinations could be represented in numbers. Red could be any number between 0 to 255. Green can be a number. Which green did I use? I think I used this green over here. Did I? Okay, yes, looks right. Green can be a value between 0 to 255. And blue could be a value the same because yeah, 0 to 255. And the really cool thing is, well, whenever I have an RGB color, so now I have this pixel, and I am telling the computer, go color this pixel and make it, I don't know, make it let's say red. So if it's red, then I would have to say RGB, some instruction over here. In Mathematica, it's RGB, okay, GB color. I'll do first how, and I would do it in Photoshop or making a website or anywhere you have to use RGB color. I would usually do it this way. If it was red, I would just say, okay, so I need 255 red, which goes into the first slot. Then you have comma, make it white, comma. I would have green, but wait, I only want this color to be red, so I don't want any green, any trace of any green. So green would be 0. So that would be 0. It's green. And blue. Well, if it's just red, I don't want green, I don't want blue either. So blue would also be, whoops, well, I have to have blue for blue. Blue, oh no, okay, it should be 0. Yes, 0. Blue is 0. 0. And when the computer understands this, okay, you know, RGB color, 255 of R, 0 of green, 0 of blue. And together they give 255 red. So this pixel would be colored red. But wait, how does this relate to, you know, the color thing we wanted to do in Mathematica? Well, I just realized I'm running out of time. So I will continue this video in the next segment of this tutorial. See you soon in the next video.